At the end of this video, you should be able to summarize how movements of tectonic plates have influenced climates and life on Earth, and describe the Supercontinent Cycle. Chapter 10, Section 3, Effects of Continental Change. Modern climates are a result of past movements of tectonic plates. A continent's location in relation to the equator and the poles affects the continent's overall climate. A continent's climate is also affected by the continent's location in relation to oceans and other continents. Mountain ranges affect airflow and wind patterns around the globe. Mountains also affect the amount of moisture that reaches certain parts of a continent. When continents move, the flow of air and moisture around the globe changes and causes climates to change. Changes in climate. Geologic evidence shows that ice once covered most of Earth's continental surfaces. Even the Sahara in Africa, one of the hottest places on Earth today, was once covered by a thick ice sheet. This ice sheet formed when all of the continents were close together and were located near the South Pole. As continents began to drift around the globe, global temperatures changed and much of the ice sheet melted. Changes in life. As continents rift and mountains form, populations of organisms are separated. When populations are separated, new species may evolve from existing species. Sometimes isolation protects organisms from competitors and predators and may allow the organism to evolve into unique organisms. The Supercontinent Cycle. Using evidence from many scientific fields, scientists can construct a general picture of continental change throughout time. They think that at several times in the past, the continents were arranged into large land masses called supercontinents. These supercontinents broke apart to form smaller continents that moved around the globe. Eventually, the smaller continents joined together to form another supercontinent. When the last supercontinent broke apart, the modern continents formed. A new supercontinent is likely to form in the future. This process, by which supercontinents form and break apart over time, is called the Supercontinent Cycle. Why supercontinents form. The movement of plates toward convergent boundaries eventually causes continents to collide. Because continental lithosphere does not subduct, the convergent boundary between two continents becomes inactive, and a new convergent boundary forms. Over time, all of the continents collide to form a supercontinent. Then, heat from the Earth's interior builds up under the supercontinent, and rifts form in the supercontinent. The supercontinent breaks apart, and plates carry separate continents, and they move around the globe. Formation of Pangaea. The supercontinent of Pangaea formed about 300 million years ago, during the Paleozoic era. As the continents collided to form Pangaea, mountains formed. The Appalachian Mountains of eastern North America and the Ural Mountains of Russia formed during these collisions. A body of water called the Tethys Sea cut into the eastern edge of Pangaea. The single large ocean that surrounded Pangaea was called Panthalassa. Breakup of Pangaea. About 250 million years ago, during the Paleozoic era, Pangaea began to break into two continents, Laurasia and Gondwanaland. A large rift split the supercontinent from east to west. Then, Laurasia began to drift northward and rotate slowly, and a new rift formed. This rift separated Laurasia into the continents of North America and Eurasia. The rift eventually formed the North Atlantic Ocean. The rotation of Laurasia also caused the Tethys Sea to close. The Tethys Sea eventually became the Mediterranean Sea. As Laurasia began to break apart, Gondwanaland also broke into two continents. One continent broke apart and became the continents of South America and Africa. About 150 million years ago, during the Mesozoic era, A rift between Africa and South America opened to form the South Atlantic Ocean. The other continents separated to form India, Australia, and Antarctica. As India broke away from Australia and Antarctica, it started moving northward toward Eurasia. About 50 million years ago, during the Cenozoic era, India collided with Eurasia and the Himalaya Mountains began to form. The modern continents. Slowly, the continents moved into their present positions. As the continents drifted, they collided with terrains and other continents. These collisions welded new crust onto the continents and uplifted the land. Mountain ranges such as the Rocky Mountains, the Andes, and the Alps formed. Tectonic plate motion also caused new oceans to open up and caused others to close. Geography of the future. As tectonic plates continue to move, Earth's geography will change dramatically. If plate movements continue at current rates, in about 150 million years, Africa will collide with Eurasia, and the Mediterranean Sea will close. A new ocean will form as East Africa separates from the rest of Africa and moves eastward. New subduction zones will form off the east coast of North and South America. North and South America will then move east across the Atlantic Ocean. The Atlantic Ocean will close as North and South America collide with Africa. In North America, Mexico's Baja Peninsula and the part of California that is west of the San Andreas Fault will move to where Alaska is today. If this plate movement occurs as predicted, Los Angeles will be located north of San Francisco's current location. Scientists predict that in 250 million years, the continents will come together again to form a new supercontinent, the idea of which is represented on the screen here. At this point, you should be able to summarize how movements of tectonic plates have influenced climates and life on Earth, and describe the supercontinent cycle.